In this video, we'll discuss how to check the function is 1 1 or onto. And in last video, we have discussed types of function based on mapping. I mean 1 1 function and onto function. And I have written one question at board for you people so that I can teach you how to check the function is 1 1 or onto. Show that the function f, which is defined from natural number set to natural number, defined by f of x equals to 3x, is not bijective. And for your kind information, in last video we have discussed if any function is 1 1 and onto both is called bijective. It means अगर कोई फंक्शन 1 1 और onto दोनों हुआ तो उसे bijective बोला जाएगा. Let us start this question. Let us work for 1 1 part. I will work for 1 1. The given function is f of x equals to 3x. Let us discuss this function by taking mapping diagrams. This is the domain, a set of natural number. I'll take number 1, 2, 3, 4, 5, 6 up to so on. I take second set, that is codomain. I'll take the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 and up to so on. Domain and codomain both are the sets of natural numbers. And we have function f of x equals to 3x. Let us give input one by one. Put x equals to 1, then I will get the output 3 into 1 equals to 3. It means when I will give the input 1, I will get the output 3. When I will give the input 2, I will get the output 6. When I will give the input 3, I will get the output 9. It means every element in its domain is having only and only one image in its codomain. Once again, you can feel every element in its domain is having only and only one image in its codomain. डोमेन के हर एलिमेंट की केवल और केवल एक ही इमेज है उसकी कोडोमेन में. And in last video we have done if any function in its domain every element is having only and only one image in its codomain is called 1 1 function. So we can feed this function is 1 1. You can ask me, sir, this is the way to prove the function is 1 1. Then I will say no. We are having algorithm and strategy to use will prove that the function is 1 1 or not. Very first I will prove that I will check the function is 1 1 or not. I will use algorithm, and later on I will tell you what is the reason behind this algorithm. So let us start that algorithm. Step number 1, whenever we have to check any function is 1 1 or not, take two arbitrary constants, two arbitrary elements. Once again, whenever we want to check the function is 1 1 or not, you have to take two arbitrary elements, two different elements. Right here, step number 1. Let x1 and x2 are different elements. Step number 1, whenever we have to check the function is 1 1 or not, we have to take x1 and x2, two different elements. You can take x1, x2, a1, a2, but we have to take two different elements, and here I have taken x1 and x2. Step number 2. Step number 2, we have to put f of x1 equals to f of x2. Step number 1, we have to assume x1 and x2 two different elements. And step number 2, we have to put f of x1 equals to f of x2. And we have to use this function now. Just replace x with x1, I will get the output 3x1. अगर मैं x को रिप्लेस करता हूँ x1 से, I will get the output 3x1. If I'll give the input x as x2, I will get the output 3x2. 3 cancel. At last I'll get x1 equals to x2. Then step 3. At last step, if you will get x1 equals to x2, then the function is 1 1. Here x1 equals to x2. This implies that f of x equals to 3x is 1 1. And now we'll discuss the reason behind this algorithm. Very first, we have taken x1 and x2 are two different elements. It means we have assumed here x1 and x2 are two different elements, and f of x1 equal to f of x2. It means both are having same image. Both are having same image. It means at the beginning we are going to assume the function is not 1 1. It means two different elements are there, they are having same image. And by implementing this function, and what we'll get at the last, x1 equals to x2. It means these two elements are not different, both elements are same only. It means ki each element is having only and only one image. It means the function is 1 1. Once again, in this algorithm, very first we have taken this assumption x1 and x2 to arbitrary elements, and we have taken f of x1 equals to f of x2, and I have applied this function, matlab f of x equals to 3x. If I replace x with x1, I get 3x1. If I replace x with x2, I will get 3x2. 3 cancel, x1 equals to x2. When at the end of this algorithm we will get x1 equals to x2, then the function is 1 1. You see, in this algorithm, very first we have taken x1 and x2 two elements, and we assumed they are having same image. It means in the beginning of this algorithm we assumed it is not 1 1, but at last step we got x1 and x2 are not two different elements, they are having one element. It means we proved every element is having one image. It means the function is 1 1. And whenever you have to prove or check the function is 1 1 or not, you have to use this algorithm. So this function is 1 1 for natural number to natural number set. Now let us work for onto. For onto function. Let us check. The function is given f of x equals to 3x. Let us use mapping diagram to feel the function is 1 1 or not. Otherwise mapping diagrams are not required. First time you are understanding, that's way you can feel the function is onto or not. Let's see. I'll take first set, that is natural number, and the second set is also natural number, and I'll take some natural number in this set 1 2 3 4 5 up to so on. I'll take 1 2 3 4 5 6 7 8 up to so on. Let us give the input and get the output. If I'll put x equals to 1, I'm getting output 3 into 1 equals to 3. If I'm giving the input 2, I'm getting the output 6. And for your kind information, in last video we have discussed types of function based on mapping, that is 1 1 function, onto function. Over there about onto function we discussed that function is called onto if each element in its codomain will have image of sum of elements in domain. Once again, that function is called onto if each element in codomain will have image of some elements इन डोमेन, यानी कि वो फंक्शन ऑन टू बोला जाएगा अगर कोडोमेन का हर एलिमेंट डोमेन के किसी ना किसी एलिमेंट की इमेज रहेगा। यू सी देर आर मैनी एलिमेंट्स आर लेफ्ट जो कि किसी की इमेज बन ही नहीं पाए। वन एलिमेंट इज लेफ्ट, टू is left, or many more are left. So whenever we have to prove one, there is a algorithm you can use at the last step. When you get x1 equals to x2, you can declare the function is 1, otherwise it is not 1. But there is no any particular algorithm. Very first you have to feel yourself the function is on to or not, then only you can write. And here we can feel many elements are left which are not image of these elements. Once again, वो फंक्शन 1 बोला जाएगा अगर कोड डोमेन का हर एलिमेंट डोमेन के किसी ना किसी एलिमेंट की इमेज होगा, यानी कि कोड डोमेन में सारे के सारे एलिमेंट्स ऑक्युपाइड चाहिए। बट देर आर मैनी एलिमेंट्स विच आर नॉट ऑक्युपाइड लाइक 1, 2, 4, 5. So whenever we have to prove the function is not on to, one example is enough. Let's see. I will write here 1. I'll take 1 as example. 1 belongs to natural number. 1 belongs to natural number. There is no x such that f of x equals to 1. यानी कि मेरे पास कोई ऐसा नेचुरल नंबर है ही नहीं कि अगर मैं x की जगह पुट करूं और मेरे पास यहाँ पे 1 आ जाए. It means many elements are left. I have taken 1 as example, and here this implies that the function is not onto. And this is 1, but not onto. It means the function is not bijective, because we have already studied if any function is 1 and onto both, then function is bijective, otherwise it is not bijective. And hence function means the given function is not bijective.